So was everyone able to read the little article and complete some of the questions on the worksheet that we posted on Google Classroom?
Yes.
Yeah.
Yeah.
Okay. And
Yeah.
yeah, good. And what were some of your first impressions? What did you guys think about the reading?
Very confusing until the bottom 3 paragraphs.
It was very confusing until the bottom 3 paragraphs? Okay.
Yes.
Yeah, because the bottom 3 paragraphs kind of go into detail of the family and the history. Okay.
Huh?
It was easy with the pedigree.
It was. What do you say it? It's unmuted.
I thought it was easy with the pedigree. Like once you used the pedigree and you read through it, I thought that was easy.
It was kind of easy, but it was just confusing because it wasn't super specific.
Yeah, so that is something we'll talk about too when we get to this pedigree question. A lot of times it doesn't say like how many or which people actually had the trait. Like it's like the one where it had several children and only like a couple of them were blue. So that was a little challenging, I thought too. Anything else that we found interesting or challenging? No? Okay, then we will just go through and we'll start with number 1. So this number 1 question, I just wanted you to kind of get your thoughts down and maybe take some notes on the reading. So what were some of the facts that you guys found about the trait in the blue people?
It was a recessive trait.
Recessive trait, okay. How did you kind of figure that out? Oh, I can't spell, guys, just a heads up. And how did you figure out it was a recessive trait?
Well, the wife of one of the people was she was heterozygous and she married the blue husband, and the only way in the Punnett square that would work for
Is that both
them
of
to
them
have like
it?
blue babies is if he was homozygous recessive and she was heterozygous.
Okay, very good. It's a very good answer. Okay, anything else? Any other facts about the trait or even the story about the family?
I said that no one exactly knows what causes the blueness, and like some people say like heart disease or something like that, but nobody exactly knows.
And we will talk about, that kind of goes to the last question too. We will talk about some of the possible causes for it too, the trait. Any other ideas or facts that you guys saw?
It kind of seems like it can disappear in certain cases, like go away for the most part.
Mm-hmm. And we saw that with Benji, right? He was born with the trait, but then it was lost over time. And we'll talk about that too. Okay, so I kind of had some other facts written down about just the story in general. So I have that they lived in a very remote area.
The incest.
I noticed that there's a lot of incest within the family.
Yeah.
This class in particular is very interested in incest for some reason. I've noticed that previously. I can't explain it, but anyway.
Yeah. Yeah, you guys actually had a lot of the same facts that I had written down. I just had in general that the trait was heritable. That way we know that, or inheritable, I probably should say. That way we know that, you know, it's not because of like environmental factors. We know it's from their genes, not from like the water they're drinking or the food that they're eating. So that was one of the facts I had written down. Okay, and did anyone else have anything different than this list we have? Okay, so now we're going to go into the pedigree, and I don't know how long this is going to take us to kind of go through. But first I want to ask you, so, ooh, okay, we're just going to go like this. So who are these 2 people up here? Can anyone tell me who these 2 people are?
He has a really cool
Martin
first
and
name.
Elizabeth.
It's Martin and his wife.
Is
Martin and his
Elizabeth.
wife Elizabeth, right? I'm just gonna put like initials so we know who they are. Bear with me while I draw on this. I have to use my mouse. Okay. And so from the reading, can anyone tell me what their phenotypes were?
Martin was blue, but Elizabeth was pale.
And
Okay.
Elizabeth heterozygous.
You think Elizabeth was heterozygous, and why do you think that? I think we kind of talked about this already, but can you re-explain?
Yeah, because so Martin was already homozygous recessive, and for Elizabeth had to be heterozygous because otherwise they wouldn't be able to have blue babies if she was homozygous dominant, because the dominant trait would overpower the recessive trait in all cases, except if she was heterozygous.
If she wasn't het, then how could they have 4 out of the 7 kids that were blue?
Yes.
Yeah, exactly. So I don't know. So one thing that can help you figure this out is if you did a Punnett square with Martin and Elizabeth, right? And you did, so Martin was blue, right? So in this case, we're going to assume he was homozygous recessive.
We're just going try hard.
So for them to get a ratio of having 4 children that were blue and 3 that were not blue, right? Elizabeth is going to have to be heterozygous for the trait. Because what kind of ratio? Does anyone know what ratio this would give us?
3 to 1.
3 to 1? Oh, yes. For the genotype, what kind of phenotypic ratio would that give us?
1 to 1.
1 to 1. Yep. Oh, someone drawing it?
I'm trying to see if I can do it with my pen, but it's probably not any better than what you're doing. I'm sorry. It's too fat. Let me get rid of it.
No, but if you do the cross, you'll get a 1 to 1 phenotypic ratio. So you'll have 1 to 1 blue skin and the other half will have normal skin. And so I'm going to just shade in 4 of these blue. We're going to go with the bigger one. Right, because the reading told us that 4 of their children had blue skin, right? There we go. That looks great. Good. And I think Mr. Volk drew the Punnett square on the right there, if you can see it.
I did mess up though. I put the male and female in the wrong place, but that's not super important.
Yeah, it's okay. So you can see that this is a 1 to 1 phenotypic ratio, right? This will give us blue skin on the left, or sorry, on the right will give you blue skin, and on the left will give you pale and normal colored skin. So from the reading, who was next? Who did they say, one of the sons, right, who had blue skin, got married? What did they say about that? Can anyone tell me?
Zachary.
Say it.
Zachary, right? So this is Zachary. I'm just going to put a Z. And who did he marry?
His mom's
Elizabeth's
sister, I believe.
Aunt.
His aunt, yes, he's married his aunt. And that's why, I don't know if you guys found this confusing, but that's why there is a line attaching the sisters together and to the son. So this shows that they're married, and this shows that these 2 are sisters. So Zachariah did marry his aunt. And how many children did they have? Or this one didn't specify, did it?
8.
7.
7.
Did it have 7? Perfect. And then how many of them were blue that we know of?
We don't know, actually. It doesn't say.
We don't know.
Mhm.
What was the name of one of the sons, though?
Levi.
Levi.
Levi?
So this is going to be Levi here. And did Levi have any blue children? Do we remember? We can go back to the reading up here.
Yes, he had 1. He had 1. Luna.
He had at least 1 blue child. Her name was Luna, right? So this is Luna down here, the one that I'm filling in. She was blue. So if we know she is blue, what do we think, what must have Levi been? It could be
Either-
two options here, kind of.
Heterozygous or blue.
Yeah, so he must have at least been a carrier for the trait. So we know he had at least one recessive allele. And Levi, we see this connection here, right? He married a Ritchie, a girl from the Ritchie clan, and she was one of his distant cousins. So what can we assume that this distant cousin might have been as well? If they had a blue daughter.
Heterozygous or homozygous recessive?
Yeah, one of those two, right? They should, this wife here would have been either heterozygous recessive or homozygous recessive. So she also had to have had the trait, at least a carrier. And it doesn't specify if they're blue or not, but for now we know that they at least carried the trait. So then going back even further to Zachariah's wife, what do we think she had to have been? If Levi had at least had the trait, do we know what she could have been?
Heterozygous.
Yeah, we're going to assume that she was heterozygous as well, because it doesn't specify that Levi was blue, so he must have had at least a one of the dominant traits, alleles, and he would have gotten a recessive from his father. So she would have had at least one dominant allele. So she could have also been this. Okay.
Mind if I interrupt for a second?
Yes, go ahead.
I just want to ask the kids something. What do we do when we don't know what the second one will be? Like if we don't know if
Blind.
it's small or big? Ah, okay,
Yep,
very good. You guys remember stuff. Yay, makes me feel good. Okay, I'll shut up now.
No, it's okay. That was good. What do you do again? Actually, do you fill
I'll
it
show you. I'll try to draw it in with my little pen thing. We draw it.
Okay.
We draw it like this. So we just put a line because we don't
Oh.
necessarily put the question mark, but just big B line, and then it could be either big B or little b.
Okay. Awesome.
It's not like an official thing to do. We just decided that's how we're gonna, like, when we're uncertain.
Okay.
All right, cool.
Thank you. Okay, so this one down here, the one that I'm kind of circling that we filled in, this is Luna, right? And she was known to have really like almost purple skin, right? And we don't know the rest of her siblings. We don't know if any of these are heterozygous or even if they're homozygous. So we're just going to kind of leave those blank because the reading doesn't go into much detail on them. But the reading does say Luna and what was her husband's name? Do you guys remember?
John.
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 It's John. John Stacy. They had 13 children, right?
Yes.
And were any of them blue?
No.
No.
No. So what can we assume then? If Luna definitely had little b, her husband then, what would have he had to have? If none of them were
Homozygous
blue.
dominant.
He would have had at least one dominant allele. Actually, we can, you said homozygous dominant?
Mhm.
Yeah. We're going to assume that he was also, he was homozygous dominant because then all of their children, what can we kind of assume all of their children, what kind of genotype did all of their children have?
Heterozygous.
Mhm. So all of their children were heterozygous and were carriers for the trait. Okay. So going forward, I don't think we know the name of this son here. The reading says one of Luna and John's children had a son, Elva Stacy. So Elva is going to be this one here. And Elva, I'm just going to put an A. He also married one of his distant cousins. And who was their son? This one down here.
Benji.
This is Benji, yep. And what do we know about Benji?
A
He was
slight
blue.
Yes, the
when he's
tree.
born. And then it went away. Yes.
And then his trait right away. So what can we kind of assume or speculate what his genotype was?
Little b,
Rose.
little b.
What was that? Little b, little b?
Yeah.
It's kind of weird because it disappeared.
Yeah.
Mm-hmm. And we'll talk about that. Did anyone else have heterozygous? Put heterozygous for Benji. Okay, so good. We're gonna assume that he was little b because he had the trait when he was born. So then what must his mother and father have been, their genotypes?
Heterozygous.
Heterozygous. Yeah, because we don't, neither of them were blue, but they must have had both carried the trait. Ooh, okay, there we go. Good. Okay, so that is the complete pedigree. Does anyone have any questions? Did I lose anybody while we kind of went through that explanation?
Yeah, I have a question. How come your letters drawn with a mouse look better than the ones I draw with my touchpad pen
You
thing?
suck, Mr. Vogue.
I don't
I was
understand.
really concentrating.
You make me look bad.
No. It is pretty tough because I have like a Mac laptop, so I have to like hold down the mouse and like move it at the same time. It's a little tricky.
I get that. I
I'm
have
sorry.
a Mac.
I'm sorry you're stuck with an inferior computer.
Thank you. Okay. But is that clear to everyone, or is it kind of confusing? Does anyone have any questions on the pedigree itself? Okay. Then we are going to move on to number 3. So these questions are all kind of speculative. So if you guys, I don't even know if there's not necessarily a right or wrong answer. So I just kind of want to hear your thoughts and ideas about these next questions. So number 3 is offer an explanation for why Benji lost his blue color shortly after birth. Did anyone have an answer written down for that? And again, this can just be like a kind of a hypothesis, right? Doesn't have to be right.
Maybe because the gene has been passed down so many times with intermixes with other families, it could be that it's not potent all the time.
Okay.
So
that's a good explanation. Anyone else have one? So when Mr. Volk kind of taught you about Mendelian genetics, right, were there sometimes like exceptions to those Mendelian genetics that he might have taught you about? Like maybe with the pink flowers or anything like that? Okay, so I don't know the complete explanation for why he might have lost his blue color shortly after birth, but one might think that it had something to do with incomplete dominance. Does anyone remember that term, what that term means?
Yeah.
Yeah. Yep.
They better remember it because it's going to be on the final exam.
Oh, thanks, Wolf.
So maybe the trait is not completely dominant or recessive, right? Maybe if you're heterozygous, so if Benji was actually heterozygous, right, maybe he only has blue skin. He has the trait, but he only expresses it at certain times, and that maybe that's an explanation for why he lost it as well. So it could be incomplete dominance. Did you, in your class, did you talk about like polygenetics?
I did not talk about polygenetics. We did talk about multiple alleles, and we talked about like certain traits that have multiple genes. Is that called polygenetics?
Oh,
That's
yeah,
not what
that's
we
what I'm
called it,
talking
but
about.
where there's more than one gene that cause it.
Yes, more than one gene.
Oh, I think I forgot what I called it. Polygenic, maybe? I think
Polygenic.
polygenic, I called it.
Yeah,
I think that's the same thing.
Yeah, polygenic.
I don't know all the
Yes, there we
up-to-date
go.
terms for all that
Polygenic
stuff. I'm sorry.
traits. No, I could have had it wrong completely too. So can anyone explain to me what polygenic traits are if you talked about it a little bit in your class? Or is it kind of hard to remember? So
That's
in
something,
polygenic,
sorry,
oh,
that's something that came up after we got locked down, and it was like shortly mentioned in one of my videos, so they don't know tons about it. I mean,
okay,
they might remember it from the video, they might not, I don't know.
yeah. So polygenic traits happens when there's more than one gene that affects like the trait that you see. So one of them usually is skin color. There's multiple genes right on your chromosomes that play into your skin color. That's why you see like not just black, white, and in the middle, you see a big range of skin colors. So that could be another explanation for this trait as well. Maybe there's more genes that play into actually showing the trait. Does that kind of make sense?
Yep.
Yeah.
Okay, so for now, for this question, we're just going to say that like an answer that we for sure know is that it does not follow normal patterns of Mendelian genetics. Again, can't spell too well. Actually, I think that's right. So Mendelian genetics, and what we mean by that is we don't know if it's actually completely dominant or completely recessive. Does anyone have any questions on that? Okay. Moving on then to number 3. So what outside factors made this trait prevalent in the family tree? So in this one, you can look back, and I think you guys kind of know this one already. You already mentioned it. So what?
Intermarriage and like incest with your family.
Yeah. And I think that is the sole reason why it was so prevalent in this family tree, right? Because we don't see this trait popping up in just like randomly, right? It was mostly in this family, and that's because, and I heard you guys are starting your evolution unit soon, so maybe you'll talk about this a little bit more. But if you start intermarrying within your family, right, you're kind of just swapping genes, the same genes within your family pool. So then the genes that are in your family kind of shrink into a select few. So that's why it's more common in a family that is going to intermarry, because like the gene pool, it's called, will kind of shrink. And so it's more common to get it. Does that make some sort of sense to you?
Yep.
Okay. The big reason is that they intermarried so that the gene was kept multiplying within their family. Okay, so what may be causing the blue skin actually? And I just kind of wanted you to create kind of one guess, one hypothesis. Is anyone willing to share their hypothesis for why they might have blue skin? Like the actual kind of like the biology behind the blue skin, not just the intermarriage part.
I would say that it had to do something with like, what was it, like the blood and oxygen levels in like their skin.
Who said that just now? Who was it? I couldn't tell.
Allie.
Allison, yeah.
Oh, nice. Good answer.
That's a very good answer. Anyone else have a hypothesis? So Allison is actually kind of on the right track. I kind of did some research. I wrote this down on my phone. I did some research on it. So Allison is almost, that's pretty close. So what happens is actually it has to do with a gene. So there's like a mutation in a gene that causes like an enzyme to not function properly. And this makes the blood, it changes like the conformational shape of the blood. And so it cannot bind oxygen as well as normal blood cells. Does that make sense? So they do have a blue coloration because of that building up. They can't bind oxygen as well to their cells. Does anyone have questions about that? Okay. So those are our last questions. So I thought this was a good activity and a fun activity because you just learned about genetics, you just finished that, and you kind of learned about genetic trees, like this pedigree. And so this is kind of exploring what happens when a gene is mutated and how you can study that and go through the steps of seeing what might be causing a genetic disorder. Okay, so that is all I have for everybody, unless there's any questions.
I just want to make a quick comment. This was, I think, a fun activity, but I think the kids all loved the corn lab a lot better. Kids, you can chime in, right? The corn lab was
Lies!
much more
Lies!
fun.
He tells lies!
Because they commented in the Google Classroom, they're all like, we love the corn lab.
Nope, we all love the blue one better.
Oh,
Yeah.
maybe I misread that then. Doo-doo, does doo-doo, is that like code for awesome?
Doo-doo? Where do you see that? Oh,
I see that in the chat. Corn lab is doo-doo.
I don't think so. Whoever also said blood oxygen levels, that was good. Cadence.
Do you think hemoglobin has something to do with that? I bet you it's some with hemoglobin.
Yeah.
In the red blood cells.
Yeah. So what happens is it mutates a molecule that does not allow hemoglobin to bind oxygen.
Yeah.
After it has been oxidized, so when it becomes, so that's kind of why they have that blue tint. What were you gonna say?
You hear about young babies that are born prematurely, like they'll have blue lips and stuff like that.
Mm-hmm.
But they'll it's not like their whole skin will be blue like these people, but you'll see parts like their fingertips and their lips and things like that. You'll see blue and I think that has to do with low oxygen in the hemoglobin too. So I bet you it's similar to, it's related.
Yeah, no, I think that's very similar.
Yeah.
This just has to do, like, that's going to be their whole life kind of, because it's in their genes, right?
What was crazy about this is that I watched some YouTube videos on this, and they said that it didn't affect their life, like it didn't hurt them. You would think
that's why
the oxygen thing would, like, hold them back somehow or cause them to die sooner or make them sick or something, but it didn't hurt them.
Yeah.
All right, I'll mute my mic. You kids can chime in and say some opinions or just do a little socializing or something here.
Yeah, I'm open to any questions. Well, maybe I shouldn't have said that, but
not any questions.
Not any questions.
They'll go crazy on that.
Well, maybe I'll ask you guys some questions. How is like the online learning going for you?
Great.
Okay. Yeah.
Absolutely wonderful.
I can't tell if you're being sarcastic or not.
No, I actually am thriving off of that.
It's a pain for me though.
Yeah. The only sad part is I can't see Mr. Volk every day. That's the worst part about this.
Oh yeah.
I can put a picture of my face on Google Classroom if you want, and you can just stare at my picture.
Yeah.
Oh God, that's creepy.
Do it, Mr. Wolf.
We're not becoming stalkers.
All right, cool. Well, we had a good turnout. If there's no other questions, we can wrap it up. Thanks for doing this, Miss Fry. This was awesome.
It was fun.
Very good.
Put together.
Hey, can you guys see the clapping reaction? Let's do the clapping reaction. Down at the bottom, you can either do thumbs up or clapping like this. Everybody
I
do
might
that.
have to unshare my screen.
Oh yeah, unshare the screen once so you can see all their faces clapping.
Okay. How do I do that?
I don't know. Did I share this? No. Did you share?
No, I shared
You
it.
shared it, so you have to unshare it.
Yeah. Pause share?
I don't know.
Did that
Are you-
work?
No. Are you on a computer? Or no, you said you're on a Mac?
Yeah.
There should be a thing
Oh,
like in
I
one
can
of the
stop share.
corners. In one of the corners, it'll say stop share.
I hit stop share. Now I feel like it's all
Or what you can do is drag the. I think maybe you can drag the shared part, and make it smaller, and make the faces bigger.
Mm.
I don't know.
now I feel like it's all
Maybe it's
closed.
a glitch in Zoom, and that on Macs you can't ever unshare. That would be horrible. That's okay.
Let's see. Oh. No, I don't know what's going on.
Okay, it's okay. It's okay. Don't worry about it. Thanks, kids, for showing up, and thank you, Miss Fry, for doing this. This is really nice. And the best part was I didn't have to do
Thank
anything.
you.
I could just sit here.
Thank you.
Thanks.
You're welcome.
Ta-da.
Thanks.
It was fun. Oh.
Hello.
Hey, you did it. Okay, now everybody do the clapping thing.
Oh.
There you go. Let's go, Hannah Billman. Let's go, Michael. Clapping. Abigail Stroshin. Now we can see the people that just logged in and then went away and never turned the camera on, but they're not actually here.
Yeah.
Can't hear us. They're like the posers, you know?
Yeah.
Let me scroll through here. Okay. All right. Can we shut it down?
I think so.
Peace out.
All right. Thanks, guys.
Bye.
I'm shutting it off. Bye.
Yeah.
Bye, everybody.